All right, get ready to dive deep, deep into Linux. We got a mountain of listener questions all about those powerful commands and core concepts. The things that really separate the Linux newbies from the command line wizards.
It's really impressive. The questions are super insightful. They're not just about rote memorization. It's clear folks want to grasp the deeper logic behind Linux.
Yeah, for sure. So let's jump right in. And, we got to start with networking because, like it or not, it's the foundation of our connected world, right?
Yeah.
And one question that kept popping up was about network ports. Why do we even need those things?
So picture this. Imagine a massive city buzzing with millions of conversations happening all at once. Now, that's kind of like your computer on a network. And these network ports, they're like dedicated phone lines in that city, making sure all your apps, your browser, email, games, everything can chat without stepping on each other's toes.
So it's all about organization,
Yeah.
keeping things tidy, making sure data doesn't get jumbled up.
Exactly, spot on. And to push that city analogy a bit further, think of subnets like zoning regulations. They split that huge city into smaller, manageable neighborhoods.
Yeah.
It's about security, yeah? And making sure that the data traffic flows smoothly.
Makes sense. Okay, so we've got our communication channels all set up, right? But if we're going to navigate this digital city, we need a map. And that's where DNS comes in. It's like the translator, turning those human-readable website names into, the IP addresses computers actually use.
Right. And think of the dig command. It's like having this incredibly detailed city directory. It doesn't just give you the address. Dig also shows you the routes, the whole infrastructure. So if you hit a DNS snag, dig can help you troubleshoot it.
Gotcha. So dig is more than just a simple lookup. It gives you X-ray vision into the whole DNS system. Okay, so we're communicating, we're navigating, but now we got to manage all that info flowing through our systems. Let's talk file management and system insights, yeah? One question that caught my eye was about awk. Honestly, it's always been a bit of a mystery to me.
So awk, it's more than just a simple command. It's practically a whole programming language right there in your terminal. With awk, you can really get in there, manipulate text data with insane precision. Imagine a massive spreadsheet. Awk can slice and dice it, pull out specific columns, crunch numbers, reformat everything just how you like it.
Whoa, so awk is like this super-powered data assistant, fluent in the language of your files.
Exactly. If you work with large data sets, log files, any kind of structured text, awk is your best friend. It's all about transforming raw data into actual meaningful insights.
Okay, I'm starting to see the appeal.
Yes.
Now, you mentioned the proc directory as this direct line to the heart of your Linux system.
Yeah.
I'm picturing a live feed from the control room. Is that right?
You got it. The thing is, proc, it's not a physical folder on your hard drive. It's this virtual window into the kernel's perspective, right? You get real-time data on your CPU, memory, all the running processes. It's everything happening under the hood.
So let me check if a program's being greedy with resources or monitor network activity as it happens.
Absolutely. It's gold for troubleshooting performance issues, understanding how your system behaves, even tweaking configurations. It's a powerful tool.
Okay, yeah, proc, I'm adding that to my Linux toolkit. Now let's switch gears a bit. File identification, yeah. What about inodes? I saw that term in the questions. Why should we care about inodes?
Think of inodes as the DNA of your files. See, us humans, we use file names, but the operating system, it relies on these inodes. They track every single piece of data. Size, location, permissions, it's all in there.
So even if two files have the same name, their inodes are like unique fingerprints, making sure the system can tell them apart.
Precisely. It's fundamental in Linux, keeps your data safe, prevents those nasty conflicts. And hey, if you ever need to find a file's inode, else tech, I will reveal its hidden ID.
This is fascinating. We've gone from this bustling digital cityscape to the very DNA of our files, and we're just getting started. Let's move on to something a bit more dramatic, process management, yeah.
And troubleshooting. Ah, yes, the world of processes, where things can get a little wild, for sure. One question that stood out to me was about, kill versus kill Nagus9, two commands that sound pretty ominous, right?
I gotta admit, typing kill on my computer always makes me a little nervous. Is there a gentler approach to handling those unruly processes?
There is. Think of kill as a polite request, asking a program nicely, hey, time to wrap up, save your work, and exit gracefully. Now, kill Nagus9, that's more like hitting the big red emergency button. It's immediate termination, no chance for cleanup.
So it's like yanking the power cord on a misbehaving appliance, a last resort kind of thing.
Exactly. It's powerful, but you got to be careful. Using kill Nagus9 carelessly can lead to data loss or even system instability, Always try that gentler kill first.
Good advice.
Yep.
Now, what about those mysterious zombie processes? I mean, are they as scary as they sound?
Not quite as frightening as the name suggests, but they can be a sign of trouble brewing. Imagine a program finishing its task, right? But it forgets to tell its parent process, hey, I'm done, like a kid wandering off in a park. The parents left searching, no idea what happened.
So the process is dead, but it's still kind of lingering in the system's memory, like a ghost.
Precisely. Now, a few zombies here and there, usually no big deal, but a whole horde of them. That might point to problems with resource management, maybe a buggy program, worth keeping an eye on for sure.
Wow, this is eye-opening stuff. We've covered so much, from network ports to zombie processes, and it's really starting to connect in a meaningful way. I'm feeling way more confident about navigating this Linux world.
That's fantastic to hear. And remember, we're just scratching the surface here. There's a whole universe of Linux commands and concepts waiting to be explored.
Well, let's catch our breath for a moment, and then we'll be back to uncover even more Linux secrets. Stay tuned.
All right, welcome back. I'm ready to dig into some more of these fantastic questions you all sent in. We were talking about proc earlier, right? Like how it's this live view into your system. Well, there's another file, etc6tl.conf. This one, it actually lets you tweak the controls.
Oh, interesting. So this is where we get to fine-tune things. Dial in the performance. I'm imagining like a sound engineer adjusting the EQ for the perfect mix.
Yeah, great analogy. With etc6tl.conf, you're modifying kernel parameters, and those control everything. Network buffer sizes, memory management, it's powerful stuff. But like any powerful tool, gotta use it carefully.
So little knowledge can be dangerous, huh? Are there any like safety nets, things that stop us from accidentally bricking our systems?
Don't worry, Linux is built with safety in mind. Most of those parameters have sensible defaults. And any changes you make, they don't actually take effect until you reboot. Still, it's always smart to do your research first, understand the impact, like reading the instruction manual before you operate heavy machinery.
Solid advice. Okay, let's get back to those commands. What about finding specific information within files? Like, I need to locate a particular word buried in a ton of text.
Grep to the rescue. It's like a searchlight. Scans through files for lines matching a specific pattern. And it's not just simple words. You can use regular expressions, to define really complex patterns.
Whoa. So grep can find anything from a single word to this, like, super specific sequence of characters.
Oh, yeah. It's super versatile. And if you need to search across multiple files, even a whole directory tree, grep can handle it no problem.
Nice. Okay. What about those times when you need to schedule tasks? Backups, updates, things like that. I've heard of cron tab, but it always seemed kind of, well, mysterious.
Think of cron tab as your trusty assistant silently working behind the scenes to execute commands at specific times. It's the automation engine of Linux, really.
Handy. But what if, like, a scheduled job doesn't run? Where do you even start troubleshooting that?
First thing, always check your system time. Cron tab relies on that being accurate. Then, double-check your cron entry, the syntax. Even a tiny typo can throw things off.
So it's all about precision, like writing code.
Exactly. And if everything looks right, next stop is varlog cron. It keeps a log of all cron activities, including errors.
So it's like a detective's notebook, giving you clues to solve the mystery of the missing cron job.
That's it. Following those logs can often lead you right to the root of the problem.
Okay, let's talk hardware for a minute. What if I need to see like a detailed inventory of my system's components? Is there a command for that?
Dmide code, that's your go-to. It pulls out everything about your CPU, memory, hard drives, network cards, the whole shebang.
So it's like X-ray vision for your hardware.
Yeah.
Shows you all the hidden bits and their specs.
Exactly. Super useful for troubleshooting, planning upgrades, or even just satisfying your curiosity.
Speaking of curiosity, what about finding the mmax address of a network interface?
Oh, easy one. Good old ifconfig, it'll show you everything about your network interfaces, including those mmax addresses.
So if config is like the network interface's ID card, reveals its unique identifier in the vast world of connected devices.
Nice way to put it. And if you're feeling modern, the ip command can give you that info too.
Okay, earlier we talked about file permissions, right? Let's say I've got a file with some sensitive info, and I want to make it completely private, like no one else can peek inside. How do I do that?
Tedmotode is your friend here. It lets you control access with fine-grained detail. To make a file only readable by the owner, you'd use chmod or our file name. Locks it down tight.
So chmod is like the digital security guard enforcing our access rules.
You got it. Essential for data security and privacy for sure.
We touched on some text manipulation commands earlier. Can you tell me more about unique and shed? What do they do? How are they different?
Both are powerhouses for working with text. Think of unique as a meticulous editor. It removes duplicate lines from a sorted list. Perfect for data cleanup, making sure you only have unique entries.
So it's like a filter removing redundancy.
Yeah, good way to visualize it. Now, sed, that's more like a master craftsman. It can transform text in all sorts of ways. Search and replace, delete lines, insert text, you name it.
So sed is like a text-based Swiss Army knife, a tool for every editing task you can imagine.
Exactly. Super powerful for automation, data cleanup, even generating reports.
Okay, I saw a command combination that always kind of intrigued me. LS, LEALT, LTR. Can you break down the magic behind that one?
Ah, yes, the classic LSLTR. It's all about listing directory contents in a specific order, revealing the history of changes. LL gives you the details, LT sorts by modification time, and LR reverses the order, so the newest files are at the bottom.
So it's like a time machine for our directory. Shows us how files have changed over time.
Precisely. Super helpful when your tracked modifications are looking for those recently changed files.
Thinking of changes, we talked about archiving and compressing files, right? Remind me, what are tar, gzip, and gunzip all about?
Imagine them as a team working together to manage your files efficiently. tar is the organizer. It bundles multiple files into one archive. gzip is the compressor, shrinks that archive down to save space. And gunzip is the expander, gets those files back to their original size.
Okay, so it's like packing a suitcase for a trip. Tar packs your stuff, gzip squeezes the suitcase shut, and gunzip unpacks everything when you arrive.
Perfect analogy. It's a common workflow for backups, sharing large files, and just generally keeping your disk space under control.
Okay, let's shift gears to operating system installations. I know the classic ways with a DVD, but what are some more modern options?
Tech's always evolving, right? So are the ways we install operating systems. These days, you can use DVD images, ISO, bootable USB drives, even network installations. It's all about flexibility.
So no more being tied to physical media. We can install from a digital image or even remotely.
Yep. Network installations are super useful in server environments when you might need to set up multiple machines remotely.
Makes sense. Now, what if I need to compare two files? See the differences between them. Is there a command for that?
Diff, that's your go-to. It analyzes the two files, pinpoints all the changes, whether it's additions, deletions, or modifications.
So if I'm working on a project with someone and I want to see what they've changed, diff will show me exactly what's been modified.
Yep, spot on. It's a must-have for version control and collaboration.
Man, we've covered so much. File management, hardware analysis, scheduling tasks, comparing files. It's incredible how much we can do with the Linux command line.
It's a testament to how powerful and flexible Linux is. And remember, this is just scratching the surface. There's always more to learn, more commands to master.
I'm feeling super inspired to open up my terminal and play around with all these commands. But before we get lost in the command line, let's take a quick pause. We'll be back to wrap up our deep dive with a look at TCP and UDP and some final thoughts on navigating the ever-changing world of Linux. All right, we're back, ready for the final stretch of our Linux deep dive. We've explored a ton of commands and concepts, but no exploration of Linux would be complete without talking about TCP and UDP, right? They're like the languages of the internet.
Yeah, that's a good way to put it. TCP and UDP, they're the fundamental protocols that kind of dictate how all this data flows across networks. And they both have their strengths, making them suitable for different kinds of communication, you know?
Okay, so break it down for me. What's the big difference between these two internet languages?
Imagine you're sending a package. TCP is like that super meticulous delivery service. You know, they make absolutely sure your package arrives safe and sound, in the right order, everything, carefully tracking each piece, confirming receipt, even resending anything that gets lost along the way.
So TCP is all about reliability, making sure the data gets there, even if it takes a bit longer.
Exactly. That's why TCP is perfect for stuff where data integrity is super important, like email, file transfers, web browsing. I mean, you wouldn't want your web page showing up all jumbled up, right?
Nope, definitely not. Okay, so where does UDP fit in? Is it like the express mail of the internet?
You could say that. UDP is more like sending a postcard, you know? It's faster, more lightweight than TCP, but there's no guarantee it'll get there. And it might not arrive in order, like a quick shout across a room. It might get lost in the noise, but it's fast and efficient for like short bursts of info.
So UDP sacrifices reliability for speed. When would that be a good trade-off?
Think about things like live video streaming or online gaming. In those situations, speed is king. Dropping a few packets might cause a tiny glitch, but that's way better than constant lag, right?
Makes total sense. Choose the right tool for the job. TCP when you need that perfect accuracy, and UDP when speed is everything. Now, we talked about zombie processes earlier. Can you give me like a real-world example of where those might cause problems?
Okay, imagine a web server handling tons of requests, right? If there's a bug in the code that prevents those child processes from properly notifying their parent when they're done, well, you could end up with a whole bunch of zombie processes hanging around.
So it's like a restaurant where people finish their meals, but they never leave their tables. No new customers can get in.
Uh-huh. Yeah, that's a great analogy. And these lingering zombies, even though they're not actively doing anything, they still hog system resources. Eventually, they can really slow things down.
Good reminder to write clean code. Now, I remember a question about finding a specific pattern in a file and replacing it. What's the best way to do that?
That's where SEDS comes in handy. It's a find and replace master. Handles complex patterns, replaces them with precision, like a superpowered editor that can make changes across a whole document in seconds.
So if I wanted to, say, replace every instance of color with color in a massive text file, SED could do that, no problem.
Absolutely. And it can handle way more complex replacements, too, using those regular expressions to define the patterns and transformations. SED is super powerful for automating text editing.
Okay, last question before we wrap up. What's the command to send a message to everyone logged into the system? Like a system-wide announcement.
That would be the WAL command, short for write all. It's basically a digital town crier broadcasting a message to every user.
So if there's a planned system outage or an important update, WAL is the way to get the word out.
Exactly. Essential tool for sysadmins to communicate with everyone at once.
Wow, we covered a ton of ground in this deep dive.
Hmm.
From network protocols to process management, file manipulation, user admin. It's amazing what you can do with the Linux command line.
It really shows how flexible and powerful Linux is. And this is really just the beginning. There's always more to learn, more commands to master, new ways to leverage Linux.
I'm feeling inspired, ready to fire up the terminal and put all this knowledge to use. Any final words of wisdom for our listeners, those eager to continue their Linux journey?
Just embrace that spirit of exploration. Don't be afraid to experiment, break things in a safe environment, of course,
Yeah.
and dive into that documentation. The Linux community is awesome, super helpful. So ask questions, share what you learn.
Well said. So to all our listeners out there, keep learning, keep exploring, and keep pushing the boundaries of what's possible in this amazing world of Linux. Thanks for joining us on this deep dive.